So continuation of question related to simple magnetism, phenomena of magnetism. Four nails are there, A, B, C, and D are tested to find which make the strongest magnet, like which one can make a permanent magnet or a strongest magnet. So one of the nail are placed against the bar magnet. So each nail, example, first we place nail A, then we place nail B, then we place nail C, and then we place nail D. Like one by one, we place these nails. The magnet is then removed. So once we place this, the magnet is removed. Now there's only nail and these paper clips are there. And then we check the bar magnet is then removed and the number of the paper clips remain attached to the nail is recorded. Like how many nails, maybe sometime what happened, the number of nails might detach or remove. So we measure how many are before and after. The question is which nail became the strongest permanent magnet. So we want to identify which became the strongest permanent magnet. So first, when we check option A, for A, when like example, the nail A was there, which is attached to the magnet first. So only it attracted two nails. And once the magnet is removed, it does not attach the nail. So it means it was behaving like a magnet in the external magnetic field, and once the magnet is removed, it's not behaving like a magnet. So it means this is not, it's a temporary magnet, or it is made up of soft magnetic material such as iron. It's not, and permanent magnets are made up of steel. So it means it is demagnetized easily. So A cannot be an answer because it was attracting, like behaving like a magnet. Once a magnet is removed, it's not behaving like a magnet. It means it's not it cannot be a permanent magnet, because permanent magnet, they should remain magnet for a longer period of a time. So A cannot be an answer. When we check if nail B is attached, like example B is attached, so first it was 2, so it is attracting two nails. But once the magnet is removed, it is attracting only one nail. So when we check, first it was 2, and then when we remove the magnet, it is only one nail remain intact. But when we check C, so C was attracting how many nails? The moment we connect C, it is attacked. 4 nails were attached when C was connected to the bar magnet. Once a magnet is removed, we remove this permanent magnet, one of the paper clip fall apart, remaining 3 remain intact. And for D, when we check, the D, it was attracting 5, but when the magnet is removed, it is only attracting 2. So we want to work out one which remain magnetized once the magnet is removed, or one which behave like a magnet or stronger magnet once the magnet is removed. So we don't have to bother about how many are attracted before. We have to just check this column, because this column shows the strength of the nail when the magnet is removed. When there is no magnet, because we want to find in which case or which nail can be a strong magnet. So how we can work out? You can just simply check the numbers of nail which are remain intact or attracted. When the bar magnet is removed, how many nails are remain intact? 3 nails remain intact with C. So it means C is much stronger magnet as compared to the nail. C is a permanent magnet or stronger permanent magnet compared to A, B, and D. That's why C is the correct answer. Is it clear? So the number of the nails decide the strength of the magnetic field. In the question, they are asking strongest magnet. So strongest magnet means the one which attract the most paper clips, the one which is having a stronger magnetic field. And the one which is having a stronger magnetic field will attract more pins when there is no magnet, because this is behaving like a magnet. So that's why when we check the bar, when the bar magnet is removed, this is attracting 2, 3, 1 and 0. So this is attracting the most. They are also magnet. B and D are also magnet, but they are weaker as compared to C. So when we write the strength, so C is the strongest, and then followed by D and then B. So they are asking which is the strongest. So in that case, C is the right answer. Is it clear now? In question 15, a student want to demagnetize. So when we want to demagnetize, this is a steel bar means like it's a permanent magnet. He uses the apparatus, he switch on the circuit for few seconds. He find the steel bar is still magnetized. So this method he found it is not working. So what should he do? Because whenever we should supply an AC, that is correct. And then either two things can be done. Either we gradually remove it out, or we reduce the current in the coil. Any one of them can be done to make it reduce the current or reduce the voltage. Voltage means how much energy we supply. So change the supply from AC to DC, that is wrong. Because if you change the supply from AC to DC, direct current is used to magnetize, not to demagnetize. So using a lower alternating voltage, or remove the steel bar from the coil when the switch is on. So what this is, because the first thing what we do, we remove the magnet out, we remove the permanent magnet out, so that it will be permanently demagnetized, as some parts experience stronger magnetic field and some part experience weaker magnetic field. Using a lower voltage, that this will be correct if they mention reduce. Instead of saying lower voltage, they should mention reduce the voltage. Because if we say reduce voltage, it means we are reducing a current, but not lower voltage. If we are keeping the same voltage, even higher or lower, that will not be able to demagnetize. And use a coil that has a fewer turns. So if you use a coil which is having a fewer turns, it will not be suitable, because we want it to demagnetize. That's why C is the right answer. Whenever we want to demagnetize, either slowly remove the magnet out from the coil, or gradually reduce the current. In question 16, a student suggests three methods of demagnetization. So three methods are there of demagnetization. What are the three methods to demagnetize? Number one, what we can do, we can use AC supply, we can use and gradually taking out, we can use heating, and we can hammering. So which of the following methods will demagnetize the steel? Placing in east-west direction and hammer, that's right. Whenever we are demagnetizing, we place in a east-west. Why not north and south? Because if we place in north and south, then the earth's magnetic field will magnetize this again. So that's why placing in east-west direction and heating it until red hot, that is correct. Removing it slowly from a coil which is carrying alternating current, that is also correct. So all the three methods are listed correctly here, which can be used to demagnetize a piece of steel or a permanent magnet. Is it clear? Question 16. Okay, question 17. Two separate experiments are done. A magnet is brought near to unmagnetized iron. And for iron, there is always like attracted towards the magnet and induced magnetism will occur. So if we bring a south pole, iron will be attracted. So what pole will be here? North. And what pole will be here? South. If we bring a north pole, iron is again attracted. So what pole will be here? South. And if one side is south, the other side will be north. So what is the pole at X? So at X, for the first example experiment, it was north pole. And what is the pole at Y in the second experiment? That is also a north pole. That's why A is the right answer. So and X, it was north pole induced, and at Y it will be south pole induced. In question 18, a train of a steel nail and a train of iron nail hang from a strong magnet. The trains are then carefully removed from the magnet. Like we remove the magnet. Originally the magnet was placed, but now the magnet is being removed. Now the question is, what happened to the train? Because we know steel is a permanent magnetic material, means it will remain magnetized for a longer period of a time. And iron is a temporary magnetic material, so it will instantly, when the magnet is removed, it will be demagnetized. It will lose its magnetic property. So when we check, both trains fall apart. That's both will stay together. That's wrong. Only the train of the iron nail will fall apart because iron is a temporary magnet and it will lose its magnetic property. And as a result, when it will lose its magnetic property, these nails will fall apart. In question 19, how can a permanent magnet be demagnetized? So you will find this question many times. So methods of demagnetization, there are three. Number one, we'll use AC coil and gradually take it out. Or number two, we can heat. And number three, we can hammer. Cool the magnet for a longer period of a time. So not cool, it should be heat. Place the magnet next to other magnets so it will not demagnetize. Either it will be attracted or repelled. Slowly pull it out from a coil carrying an AC supply. That is true, because if we remove it out from an AC supply to a coil which is carrying an connected to an AC supply, that will demagnetize. But here DC supply, it's not for demagnetization, it is for magnetization. So C is the right answer. Then in question 20, iron is used as a core of a transformer and steel is used to make a bar magnet. Which statement explain these uses? Because iron, what is iron? Iron is a temporary magnet which can easily magnetize or demagnetize. So iron is a magnetic and steel is non-magnetic. That is wrong. Both are magnetic material. Iron is a permanent magnet. That is wrong. Iron is temporary magnetic material. That's right. And steel is a permanent magnetic material. Means it remain magnetized for a longer period of a time. So C is the right answer. A bar magnet is placed inside a current carrying coil. The diagram shows four different experiments. In which experiment the magnet is demagnetized? Number one, we should have AC supply. How we know the AC supply? Like AC supply, this is a symbol for AC supply. So when we check this plus minus, this is wrong. This is also plus minus wrong. This is a DC supply. So this is AC supply and this one is AC supply. So 1 and 3 we have AC supplies, and either we remove the magnet slowly out or we reduce the current. So both ways it will be demagnetize. That's why B is the right answer. So whenever you want to demagnetize, you always use AC supply. DC supply is used to magnetize a material, not to demagnetize. In question 22, a steel bar is placed in east-west direction to demagnetize. No other magnet is there. Which method is not suitable? Like which method won't work? Hammering, yeah, that will work because we want to demagnetize. Heating the bar at a high temperature, that will also work. Slowly taking the bar out, carrying a current, that will also work. But slowly taking it out from a DC current, it won't work, because whenever we want to demagnetize, we always use AC current in the coil, not the DC current. In question 23, a piece of steel is slightly magnetized. It is hit several times with a hammer. Which effect will have on the steel if we place parallel to magnetic field? Like example, if we say this is the earth magnetic field, north, south, east and west. If we place parallel to magnetic field like this manner, and we place perpendicular to the magnetic field, right angle to the magnetic field. So whenever we want to demagnetize, it should always place right angle or 90 degree. Like example, if this is a magnetic field, we should always place 90 degree, or we should place east-west direction. East-west is actually, because the earth magnetic field is north to south, so east-west is the 90 degree. So whenever we want to place, we want to demagnetize, we should always place perpendicular to the earth's magnetic field, or east-west direction. So if the steel is right angle means 90 degree to the weak magnetic field or to the earth's magnetic field, because earth's magnetic field is weaker. So what will happen? It will be demagnetized. But if we place parallel, so it will not work. It will not be demagnetized. It will remain magnet. So what could be the right answer when we check? When it is placed 90 degree, it will lose its magnetism. And when we place parallel, it won't lose its magnetic property. So B is the right answer for this. Is it clear? Question 23. So whenever you want to demagnetize, you should always place 90 degree to the external magnetic field. In question 24, two soft iron pins are suspended from pole S. Which diagram shows how the pins are deflected? Look, if they are connected to north pole, so this will, if sorry, south pole, so this will be north and this will be south. And same thing, this will be north and south. And like poles or like charges repel each other, so they should move away from each other. So A is wrong because they are attracted. So A is wrong. B is also wrong because if north south and north south are there, they will also repel. It means they are in the same distance. C appear to be right because when the poles are induced, the like poles repel each other, so they push each other away. That's why C is the right. And D is totally wrong because one remains straight and another one is attracted towards. So whenever poles are induced, like poles, if they are facing, they will repel, and unlike poles will attract. So in question 25, this is a structure question. Student want to demagnetize a permanent bar magnet. She suggests three steps. Student suggested that three things should be there. Place a magnet in a long coil, that is correct. Switch on the large current, that is also correct. Then switch off the current and remove the out. This is wrong, because what we should do, we should not directly switch off the current. So state and explain whether steps will be able to demagnetize. So your answer will be no. And what is the reason for that? Because the current should not be switched off it should be either decrease and taking the magnet out. So we should not switch off the current, we should gradually reduce the current and take the magnet out so that it will be demagnetized. So this switching of the current is wrong. The point 3 is not the correct thing. Remove the bar magnet from the coil, that is correct. But here what we should do, instead of switch off the current, we should reduce the current and gradually taking the magnet out from the magnetic field. Figure 10.3 shows a view from a wire. So this is a wire. When a wire is producing a magnetic field, if we are closer to the wire, there will be a stronger magnetic field. If we are away from the wire, there will be a weaker magnetic field. So they're saying state the magnetic field at S. We want to state the magnetic field as S, T, and W. So state the magnetic field as S, T, and W in terms of magnetic field as R. So compare with R. R is away from the wire compared to S. So where it will be at S, it will be weaker magnetic field, stronger or same strength. So because S is closer to the wire, so closer to the wire, there will be a stronger magnetic field. And at T, you can see T and R are at the same distance from the wire, and T and W, R and W is also at the same distance, so they will have the same strength. If the wires, if the objects or points are same distance from the wire, it means they will experience the same strength of a magnetic field. But if the point is closer to the wire, it will experience a stronger magnetic field. Then in question 27, a permanent magnet is made from one material. Underline a material from which it is possible to make a permanent magnet. So permanent magnet, not aluminum is even not a magnetic. Copper is wrong. Soft iron is a magnetic, but it is not for permanent. Mercury is wrong. Plastic is wrong. Uranium is wrong. So correct answer is steel. Steel is used to make permanent magnet. If they say, if in the question they ask underline the magnetic material, then we will underline these two. But because they're asking for permanent magnet, so that is only made up of steel. Iron is not used to make permanent, it is used to make temporary magnet. Describe what is meant by the direction of a magnetic field and state the direction of magnetic field. So what is the direction of a magnetic field we have to draw? So magnetic field direction is always from north to south. And what is the meaning of what is the meaning of direction of a magnetic field? It means the region around the magnet where the other magnetic materials can experience a force. And put a ring around the name of a metal which are attracted towards the magnet. So we have to put a ring around a magnetic material. So we have iron and steel are the magnetic material. Then part B, on each diagram label the poles. So how we label the pole? These are the magnetic field lines. They are always out from north and into south. So this will be the north pole and this will be the south pole. and the other figure as well. So magnetic field lines are always from north to south. So this will be a north pole, south pole, this will be north, and this will be south. Because always opposite poles are there. Like if one end we have north, the other side we will have south pole. Then an electromagnet consists of a solenoid that is made up of copper wire. So solenoid, a circular wire, it is made up of copper, and inside a solenoid we place iron. So the structure, explain why the structure of copper make it suitable material for wire. Like why the wires are made up of copper? Because copper is having free electrons and conduct electricity. And iron is suitable material for the core of electromagnet. What is the reason for that? Because iron is a magnetic material which can be magnetized and demagnetized easily. So these are the questions related to exercise about simple phenomena of magnetism.